you the principles of concentration and volume, right? So in which formula we can find the concentration and the volume? Okay, there's a lot, right? If you know how to derive. But let's focus, hindi na tayo lalayo for dilution concentration, right? So for example, guys, if I have here a container of water and let's say a solute, any kind of solute for the purpose of discussion, something like this, okay? Like this. And this is the water when, for example, sodium chloride. Okay. Assuming the sodium chloride the same amount. Okay? Like that. And then only the volume changes. This is A, sample A. In sample B, we have here the volume rises like that. So your volume rises, it will happen to your solute particle. The solute particle will spread too much because there's enough space among the other. Okay? So it will, the distance will be apart like this. Okay, this is B. Now volume is increased, right? So volume B is greater than volume A. Oh, ganun. So what will happen for your concentration? So concentration A. Okay. So originally your concentration A will be more or higher because they are compacted with each other, and there's a strong intermolecular forces among the other because there's not enough space to move. Okay, they will collide with each other like that. So very strong, there's a strong kinetic energy, then higher concentration of A. Okay, now in B, concentration of B, what will happen if the volume will increase? So too much space, move farther apart the molecules or particles. So intermolecular forces are not so strong. Therefore, your concentration will decrease. Okay? So we need to say concentration is inversely proportional to the volume. When your concentration increase, your volume will decrease in a dilution, something like that. Okay? You got the point, mga palangga? So in which reality, because in our first example, we introduced 200 milliliter and it becomes 400, right? Milliliter, you get the point, solution. Ganun siya. And if you also notice in our first problem, the concentration, then you can prove that here also in this theory. Okay? So inversely proportional with each other. Okay? So this is the principles of concentration and volume in dilution and expression of concentration. Okay? Now, for example, also, if I will relate that to temperature and pressure, what will happen? But too much, right? So, we just limit to only volume and concentration, okay? Meaning to say we limit to the, what do you call this one? Extensive property of the concentration of the molecules. Okay, measurable quantity. You get the point? Ganon. Okay. So question number 2. Ganon. Ganon talaga? Okay. Nakakalok. Tama ka lang nga. Kumitad. Okay, sige siya gamay. Okay. 37 milliliters of 0.29 molarity of potassium iodide solution is required to completely react with 42 milliliters of of plumbous nitrate or lead 2 nitrate solution. What was the concentration of nitrate in lead 2 nitrate solution, di ba? Okay? So, lead. Kung saan yung lead? Lead, PB, di ba? Lead. PB. So, na-share PB positive 2. And we have also PB positive 3. They have plumbous. Okay, plumbous and plumbic. Right? So, or we will see plumbous lead 2. And then plumbic is lead 3. Just like, for example, iron in the corrosion process, the interaction of iron in the acid rain or in rain or in moisture, we can produce a rust, RUST, ferric chloride solution, right? So we have iron is Fe. So Fe also we have the ferrous positive 2. Okay, ferrous. Okay, you will see also iron 2. Okay, we have also ferric. Fe positive 3, this is ferric. So your iron 3. So in the naming of the compound, you will use this either this lead 2, lead 3, iron 2, iron 3 in your naming. Or plumbous, plumbic, ferrous, ferric. For example, I have like this FeCl, right? And then like this, okay? 2, like that. So, ganon. So others will read this as an iron chloride, but be careful. There are two forms of iron. Actually, that's too general to consider. Okay? You get the point? Because you can also like having like this FeCl3. Okay, the FeCl2 is the ferrous chloride or iron 2 chloride. But you never say iron chloride only because there's two charge for iron. So actually that is wrong chemistry grammar. You get the point? Okay, so not only English grammar but chemistry grammar. So we have also FeCl3. This is actually ferric chloride because 3 charge transposed to the other side. And then this is also iron 3 chloride. Okay? So, if you say iron chloride is wrong. Unless you will put the parentheses mentioned in the statement in the book. Meaning to say that iron chloride is in positive 2 state or form. But if there's no parentheses beside iron chloride as a general term, it is wrong because there are two forms or existence of this ferrous chloride and ferric chloride. Okay? Get the point? But for the purpose only of understanding, you need to be particular. But for computations, problem solving, and computation of the composition, it matters a lot. Get the point? So, no na siya. Now, maingon man ko guys, na ano siya? FeCl3. Okay. Ang uban, maingon ko sila nga iron trichloride. We have the rule in chemistry, okay? Like this. You will never see iron trichloride and you will never see also ferrous trichloride. Why? Because this is an ionic compound. Okay? An ionic compound rule, like RULE or PALC, ionic compound, you can never name that through numbering. Tetrachloride, like that, trichloride, tetrachloride, pentachloride, like that, because it's only applicable for molecular compound. So this is really the rule. Di ta magpataka. Okay? You get the point? And then the molecular compound, it should be non-metal and non-metal only. Okay, non-metal and metal. For example, hydrofluoric. Ganon-ganon. Diba? Because fluorine is a halide, it's not a metal. Okay, it can exist as a diatomic gas at its pure state. Okay, that's why Cl2, F2, I2. Okay, so we need to say iodine gas, chlorine gas, fluorine gas, and then it can also exist as a halide, fluoride, chloride, bromide, iodide, astatide, like that. Acetyl is not common, but they belong to the same group with the halide family or halogen. Halide group and halogen family. You get the point? Because the family is horizontal. The group is vertical. The group or period is yes, and the row will be family. Just check that over in that periodic table. There's also a policy and rule. But I am really sure that the vertical is the group. Correct me if I'm wrong, ha? Because that was 20 years ago. But that's what I understand. Okay, group A, group B, group C, group 1A, group 2A, group 3 is a vertical shaft or column. So as what I remember, if you say group, that is also the group. Oh, yes. And then the row will be the family. Never mind. Okay, let's review for yourself, ha? Nakaloka. Okay? Muna siya may tabo, guys. Okay, so, for example, if I will compute the rest chemical reaction or kalawang chemical reaction, so I have to say, iron solid, so iron solid, and then plus water. Okay, so the water could either be an acid rain, a rain, moisture, or rainfall, drops of rainfall, or any kind of water potable like this, whatever, river, creek, sea, as long as it is water. So your reaction will be like this, okay? Ferrous hydroxide. Okay, ferrous hydroxide, balance the chemical reaction like that. And then there's another elementary reaction after that, okay? Balance, tulot-tulot, ganon. Tulot-tulot. Okay. And then oxygen to, ganon. So fluoride, 4, ganon. 2 oxygen 4. So 4, ganon. So 8, ano ka? And then you'll balance the chemical reaction. Okay? Ito po yung mga palangga. Okay? But if you have this H2O, it will release hydrogen gas, right? Correct me if I'm wrong. Okay? Because a metal, when added to a water, it will yield hydrogen gas. It's gonna be iron solid plus water is equal to ferrous hydroxide. Okay, ferrous hydroxide ng gano'n, chuchu, plus hydrogen gas. Okay? Like that. So, balance the chemical reaction, charot. Okay? And then if you have the other version of the rust, which is more popular, especially if the rust will have color, let's say, yellowish, or turn into a red something, that become now ferric chloride. Okay, so iron solid, okay, plus, let's say, an hydrochloric acid in nature. Okay? In nature, did not buy this hydrochloric acid in the market, but it's just appear by nature. So it will become ferric chloride, like that. Okay? Ganun chupa-chucho. Okay? Ferric chloride. Okay? Then balance the chemical reaction, ganun. Okay, diba? So, ganun. Okay, then plus H2 rin dari-ari. Okay? Okay. Anak siya may tabo. Okay? H2 and ferric chloride. Release gapon siya ang hydrogen gas. Okay, so this is also the rust. Like that. Okay? So ferric chloride and ferrous hydroxide are all types of rust, but the ferric chloride really is the yellowish to reddish color of the rust. Halawang. Okay? Something like that. Okay, ito po yung mga palangga. Okay. I don't have to expand more about that. Okay? Okay. Isa mo itong mga reaction na, oy. Okay, mga palangga kayo po. 37 ml of point question number 2 na pala yung mga ato. So, So, 37 ml of 0.29 molar, sorry siya guys, molar potassium iodide solution. Ganon. Is required. Okay, is required to completely react with 42 ml of so I will say plumbous nitrate or lead to nitrate. So the formula is PbNO3 2 and then solution. Okay. And then what is the concentration? Liquid siya guys. what is the concentration of nitrate? Lagyan siya, turuan mo, in lead to, okay, lead to solution. Lead to nitrate solution. Okay? Ganon. So again, 37 milliliters of 0.59 molar of potassium iodide solution is required to completely react with 42 milliliters of plumbose nitrate. Yes, solution. What is the concentration of nitrate in lead to nitrate solution? You can have two types of solution here. You can use the conversion dimensional analysis solving, and then you can also have the dilution. Some prefer dilution, and some prefer the longhand method of solving, especially to those higher IQ. They love the conversion way. Okay, but I think most are liking this dilution in 1v1, because M2v2, M2v2, in 1v1. Okay, like that. Okay, so let's first use the first version. Okay, version 1. M1v1, M2v2. Okay, and because we're talking here of molarity. Okay? Because if you talk also with normality, you will change this to N1, V1, M2v2. Okay? Claro. Okay, now this is our M1. To save space in our whiteboard, I must label directly to the problem, right? And then, okay, that is our M1. Ganon, naka-N1. Ganon. And then, our V1, nakuka, 37, check. Ganon. Let's check comprehension. Okay, then M2, we have the volume 2, 42 milliliters. Check. Okay, and then okay, molarity 2, right? What is the concentration of nitrate in that? But take note, guys, what is being asked is the concentration of nitrate, not the entire plumbous nitrate. There's a difference, guys, because the plumbous nitrate is already a solution, but this nitrate is only a compound or a polyatomic ion in that solution. The same in the first example we have, in which we only take the volume of the water, not the volume of the solution. But in here, the concentration, not the volume. Same story. Okay? Meaning component only of that particular solution or mixture. Okay? Yes. And then a V2 like this. Okay. In this case, as what I discussed a while ago, we can directly put the milliliters, not necessarily convert that, because we can cancel that left and right, the ml will not matter. But if there's no volume in the other side, convert first the volume to liters. Okay? Get the point, mga palangga? Ano na siya? Okay. Now, M1, substitute galore. Ganon. So, 0.29. I will show you how. Right? Moles per liter. I will not convert the volume, right? Volume 1 is 37 milliliters. Oh, ganon. So, M2, molarity 2. And then, molarity 2 is the plumbous nitrate solution, na mga kalangga. Okay, volume 2 is 42. So, ang ml, makancel mo siya. Oh, cancel mo siya diretso, guys. So, you don't have to worry, right? You got the point? Ganon. So, in this case, actually, most of siya, this is also the tricky part of the molarity and the molarity, guys. We have, that's why the others also prefer the longhand way or conversion factor to solve. Because nang mga most chuba-chuchu, you need to take account the stoichiometric number of moles in the chemical reaction. It looks like it complicates a little bit. Maglibog ko, okay, before, okay. Then now, let's check, because it's not always substituting directly, okay, in this equation, because especially if your reaction needs a lot of number of moles to be balanced in your chemical reaction. Good only if there's no higher than 2, only 1. Okay, I will show you how. Okay, so, okay, we have potassium iodide. So, potassium iodide, okay, solution lang siya. So, I work with water na siya. Okay? Potassium iodide solution, ganon. Like that. Okay? Then, react with plumbous nitrate solution also. Okay? Plumbous nitrate solution. So not necessarily putting solution all the time. We need to say this is already a compound, but solution individually. Okay. Now, what is your product? Again, double displacement and double replacement type of chemical reaction. So we have, okay, lead iodide, okay, or plumbous iodide. Okay? Plus, ano siya, ganun. And this is potassium nitrate. Okay? Like that. Then balance the chemical reaction with visual inspection. Okay, K, charot, okay. I, charot, okay. Lead, charot, okay. Nitrogen, okay. Oxygen 6, okay. Diba? Now, take note the individual charges. Okay. Potassium 1, iodide 1, balance. Meaning to say that is really an ionic, right? A ionic compound, right? Okay. This one, plumbous, 2, nitrate negative 1, okay, like that. And the product will be lead. Lead has 2 charges, right? 2 and 3. So you need to transpose this 2 here. It will become 2 here. Ganon. Okay? You get the point. And then, potassium nitrate. Okay, potassium is positive 1 charge. Now, balance again. Okay? Potassium, lead, okay? Iodine, so 2 here, so 2 here, ganon. So, potassium 2, okay, Really? Yes, really. Nakakaloko. Okay. And then, oxygen 6. Okay, naman siya oxygen 6 na oxygen 6 na ako siya dirara. Okay, so 6 times 2, 12. So you should put also 2. Ganon. Di ba mga palangga? So, ang nitrogen mo mga palangga is 4 na siya. Yes. Okay. Ang lead mo is 2 na. So, you're gonna be putting 2 here. Okay? Ganon. Okay? So, 2. So the lead will be now becoming, yes, that's 2, right? So 2 lead, check. Ganon, yes. Iodine is 4. Iodine is 4, so you need to put 2 here, so it is 4. Potassium is 2. Okay, potassium is 2. Kaya hindi na iyaha, so 2 ang potassium. So, like this. Okay, now this is trial and error method. Kung did you ko ganahan nanin trial and error method, guys, I will use algebraic expression balancing chemical reaction, ha? Okay. Kapag ising assign of number ito, mga roman na itong balancing, use the algebraic balancing of equation rather than the trial and error method. Okay? I don't like it will confuse me. So I'm not really that, expert about putting directly the number of rows. Okay? I will use the law of conservation of mass. Okay. First, potassium. Potassium on the other side, balance. Right? Ganon. Okay? Ganon. Iodine. Hindi siya balance. So let X, iodine out beside the I. So that is X times 1, X. Okay, and then 2 on the other side, so X is equals to 2. Put 2 here beside the iodine. Okay, and then lead. Lead is equal, right? Yes, equal ang lead mga palangga. Now, nitrogen mga palangga, pila. Nitrogen in the left will be 2. Nitrogen is on the will be 2. Okay, potassium is 2. Okay, 2 potassium and here 1. So 2, let X, the number of atoms of potassium in the right side. So that is X. So therefore X. So solve X is equal to 2. So put here 2. Okay, in potassium. Ganon. Okay, papas. Okay, balance ang potassium mga palangga? Yes, balance na. Okay. And then nitrogen is 4. Okay, nitrogen is 4. So here is 2 only. So 2, so 4. and then put x beside the lead here. So 2 times x, 2x, 2x, x is equals to 2. So put the 2 here. Okay, mga kaluka? So put 2 here beside. O, ganon. Okay, muna na siya sa nitrogen. So oxygen, 6 plus 6 times 2, 12. 6 times 2, 12. Okay, balance na siya. Okay, since we have this lead 2, and then you have to put also lead 2 here. Okay? Okay, ganon. Okay, muna siya nagtago, guys. Okay. Okay, mga palangga. O, di ba? So, nabalance na siya. 2 potassium, nitrogen. Nitrogen is 4. Nitrogen is 4. Oxygen is 6 times 2, 12. So, 12 po siya. Okay, then iodine is, 2. And thrombus is 2. Okay, like that. So, okay. 2, this is not balanced, guys. No. 2B. Oh, yes, balanced na siya. Sorry. Okay. But look at your iodine. Iodine is put also okay. Like this. 2 here, so it become 4. Potassium. Ganon. Okay? So 4 potassium iodide plus 2 moles of plumbous nitrate. 2 moles of plumbous nitrate. Ganon. Lead iodide plus potassium nitrate. Ganon. Ba ni siya? Yes. Mao siya. Okay, balance na ba tayo ng mga palangga? Okay, take note. Okay. Balance na. Okay. Sure? Let's take a last look. Na-balance na ba siya? Potassium, 2. Okay. Drang sa mitri-ari. Okay. We need to rebalance this one because it's only 2. Okay. Again. Yung ano yung balancing guys, hadugay ko na siyang mga nasay guys, especially kung tatas ko siyang moles. Okay, mo na siya rule. That's why I use algebraic because I don't want the trial and error method. Okay? Makakaluka. Diba? Okay. Ganon. Okay. In my case before, if too much na kayo nagawa ng akong papel, akong usbol ang chemical reaction. Dagan na kayo mga what gaze ba? So, atong usbol ang chemical reaction kay murag hugaw ra siya tan-awon to make it clear. Lah, nahugaw gid siya. So, ganan. So plumbous nitrate. Okay. Ganon. So, ganon. So, plus, okay, potassium iodide. Okay. So, before you produce the product, i-check lang nato ang charges gaano or equal na ba. Akong iwag kanina is, I produce the product all, and later na ako ibutang-butang ng mga charge. But the best thing is that when you add the reactant, ensure the appropriate and correct charges na siya talaga so that you will not be confused sa product. Okay? Like that. Okay, our product now here is potassium nitrate. Okay, di ba? So potassium nitrate. Nitrate is -1, potassium is 1. Okay. And then we have also plumbous iodide. Right? Plumbous iodide is nitrate. O nga palangga, di ba? Okay. Now, lead balance, potassium balance. I2 is not balancing. I need to start again to visual inspection trial and error method. And later, if we cannot make it again, proceed to algebraic expression by balancing the chemical equation. Okay? So we have 2 potassium. Okay, 2 nitrogen, oxygen 6, lead, like this, blah, 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 so and so. Okay, balance na siya, guys. So, the error I committed a while ago is very simple. I created the product and the reactant immediately without putting charges first. So basically, put charges first in your reactant and produce the product so that you will never be confused. Because I'm very, very confident. Too much confident, it will lead you to, what do you call this one? Too much confident, it lead you to errors. Okay? That's it. And I think that's the most mistakes I had before. Okay? Overconfident. Okay? Like that. So, ganun siya. Mananamtani guys, no? Ako yung substitute, but this is not yet true because our plumbous nitrate is 1 mole. 1 mole of plumbous nitrate. And we have 2 moles of potassium nitrate. Okay? Now, we focus on the solutions that have nitrates because our problem states nitrate man siya. What is the concentration of nitrate? So you don't need to worry about potassium iodide and lead iodide, plumbous iodide. Focus on the nitrate chuba-chucho. Okay. Now, naon mo siya pagsabot, guys. If there is 1 mole of plumbous nitrate, originally, it will produce 2 moles of potassium nitrate in your entire chemical reaction to make it complete or to make it balance in a dynamic equilibrium, something like that. Okay, then you have also 2 moles of potassium iodide for the sake of conversation. 2 moles of potassium iodide to yield also 1 mole of lead iodide. Now, our here in the E1V1 is our potassium iodide. Okay, because here, potassium iodide, yeah. Okay, and then our being asked is nitrates, mo focus sa nitrates, as what I mentioned earlier. So this is our nitrates, chuba chucho, this M2V2. So basically, we are here, potassium nitrates. Okay, potassium nitrates. And then we have also the lead nitrates. So sa amin mo this is potassium iodide. So solution man siya, sumild siya, inani siya sa potassium nitrate. So ano ulit pagsabot, guys? So 1 mole of lead nitrate. So ganon. Okay. Will yield 2 moles of potassium nitrate. So that we have ratio to follow during our calculation. Diba? Ano siya mga kapatid? Okay? Like that. And we have also 2 moles of iodide. Okay, 2 moles of iodide, potassium iodide, and then 1 mole of plumbous iodide. And then use now the ratio and proportion in algebra, in math. Okay, like that. So we will erase this one na mga palangga ha. Because no space na siya. Nabalas naman nato, guys. Okay? Ganon. Okay. Diba? Okay. So, sa itong product, mo na potassium nitrate, dara, o dara. Okay, dara. Okay? Muna siya. So, ano yung pag-ingon nga? In every 2 moles of potassium iodide, okay, so 2 over the potassium iodide, right? And then, okay, grammar ng iodide ko. Okay? And then it will produce the lead iodide. Okay, meaning to say, or plumbous iodide 1 over lead iodide. Okay? It's also equal to 1 mole of plumbous nitrate. Okay? Ganon. Diba? And also equal to 2 moles of potassium nitrate. Diba? Diba mga kapatid? O, ganun siya. 2 moles of potassium nitrate. O, ganun. Now, magpili ka niya sa ang suwa pasok sa banga sa imong calculation using this stoichiometric relationship. Okay, kasi pasok sa banga. Okay, so potassium iodide is 2 moles. Lead iodide is 1 mole. 1 mole plumbous nitrate, 2 moles of pasok na natin siya. Okay. Okay, asa mo na mong kung anong anak niya. Okay. Now, in your problem, guys, it was mentioned what is the concentration of nitrate in lead to nitrate. So, pag itawag din mo dari, lead to nitrate solution, it's gonna be this one. Right? The concentration of nitrate in this one. Okay. And then, wala itong pangita that's being asked. Now, we have already the potassium iodide as usual. So, we can say this by ratio and proportion. This one, you will try to equate this one. So, you will say 2 over, okay, Ki, okay, is equals to 1 over plumbous nitrate or lead to nitrate, right? Okay. Now, crisscross that one, crisscross, it will become 2 times plumbous nitrate. Okay, so 2 times plumbous nitrate, okay, ganon. And then 1 times potassium iodide. Apply this in your dilution, this expression. 2 times plumbous nitrate, okay? And your plumbous nitrate is in M2V2, okay? So you'll put the 2 plumbous nitrates. So this is gonna be molarity times volume times 2. Okay, because this plumbous nitrate is already the expression of your concentration and your volume. And there's still 2, put the 2 beside, okay? And then the 1 times Ki, the Ki is already 0.29 times 37 times 1. But 1 is the same as nothing in math and in chemistry. You don't have to put. Okay? Wala na ito, stoichiometric relationship, how to solve. Okay? 2 moles. So our answer here is very maliwanag pa sa sikat ng araw that this is lead to nitrate solution in this dilution. Okay? Your answer. Okay, what is your answer? Okay, mga palangga. So, 42 times, di ba, 8. 2 siya guys ha. Huwag ko dito pagi. Ang ito, marang 2. Charot! Di ba? Nakakaloka. Okay, so, ano siya? 0.29. 0.29 mga palangga. Umitad. 0.29 times 37 is equals to divided by 42 times 2. Okay, 42 times 2. Ganon. Okay. So, ilan na siya guys? 84. So, 0.29 times 37 divided by 84. So, you have 0.1277. Take note, 0.1277 molarity of your lead to nitrate solution pa siya. But now, the problem asks only for the nitrate. Okay, the concentration of nitrate only out of this lead to nitrate solution. So, it's not the same, right? So, nitrate is a polyatomic anion with a negative 1 charge. Okay, now, you will dissociate this lead to nitrate solution na in water. Okay, not the chemical reaction already. Dissociation na yun siya because of molecules of solute na ang kinahanglanan natin na. Okay? You get the point? So, plumbous nitrate, ganun ba lang chuchu, is equal to the Pb positive 2. Why positive 2? Because it's mentioned lead 2. We are very short. Lead 2 in the problem. So, plumbous 2. And then, plus nitrate. Okay? Negative 1. Now, balance the chemical equation. We have 2 in the parentheses, and then you have to transpose that in the coefficient beside the nitrate. Ganon. Then, balance now. Pb balance, nitrate 2, okay, oxygen 6 balance. So, we have 1 mole of lead, and we have also 1 mole of this plumbous nitrate. But that is not nitrate. Okay, we are concentrating on the nitrate. So we have 2 moles of nitrate. Okay, with 1 mole of plumbous nitrate will yield 2 moles of nitrate, polyatomic compound. So we will use this stoichiometric relationship. O ganon. So 2 moles of nitrate. Okay. So, you get the point mga palangga. So that is 2 moles. So, mag-complete na sa molarity of the nitrate, ganon. Molarity of the nitrate is equal to, since you have na the molarity here, na 0.1277, again, convert na punta. Hindi mo na sa conversion. Okay na. Naakay 1.7 imong solution, nagamit yung chuchu. Or pwede naman yung edit. So guys, katong theory niya, mana ka nga. Molarity is equals to 0.1227 of the solution times the charge of the nitrate of the moles. Nakatong 2. Ito rin mo siya 2. Muna na siya answer. But we need to emphasize why we obtain 2. It's not enough to say 2 directly because kuan, dito sila, tumula sa yung formula. Okay, di ba? Anak ka na, lumbos, nitrate, ganon. Abi na ito diri mo, ano na yung i-multiply. So, dili siya, kaya basta lang higayon yung ari na siya. Okay? So, ang uban, dito na nila na ito, kaya tungkol kaya ang tuna at sa tupad sa nitrate. No, it's not like that to understand. Okay, we need to make this clear. The computation. So 1277 molar, which is moles per liter, ganon. And this is lead nitrate solution. Okay. Stoichiometric relationship. Charot. We have 1 mole of plumbose nitrate solution. Okay, that will yield 2 moles of nitrate ion. Okay, 2 moles of nitrate ion in your numerator. O, ganon. So, cancel. The unit will be moles per liter. This will be now your concentration of your nitrate. Okay? So, ganon. So, 0.127 times 2 yapon siya, which is 0.2554. But I'm just emphasizing the correct way of how to solve it. Okay? 0.2554 is the answer. 0.2554 molarity or moles per liter of your nitrate. Ganon. Okay. So, ni-increase ang iyang concentration from 0.1277 because it was multiplied by 2. Okay? Because the plumbose nitrate will dissociate. If it dissociates, it will increase the concentration. Okay? Normally, if we have the reactant and it produce the product, the reactant will yield a decreased concentration because it will give up to the product. That's the case here. From 0.1277 originally, the plumbose nitrate, it will become 0.2554 in the product, which is the nitrate and the nitrate ion and the lead. Ganon. So it looks like easy to solve, but there's a lot of chuba-chucho. You know the point? Sikot-sikot galore in here in the M1V1. Okay? So, others will just substitute immediately without considering the moles. Again, it will be wrong. So, this M1V1 into V2 is just a BTIC formula. BTIC, meaning it will trap you. And you will say, this is the answer. This is not the answer. You need a chemical reaction, you need a dissociation reaction, like that, blah, 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 chuba. Okay? Because also, why? In the sample problems of our instructors, they will never also ask in their sample problems each quantity example. For example, this one, lead nitrate solution. The sample problems also of our teachers always also, what is the normality of plumbous nitrate solution? You will never give an example of asking what is the concentration of nitrate in the plumbous solution, plumbous nitrate solution. Always the compound they will ask. So, muratag maanad in the future. Actually, dili na siya mo, gibungkag na ba guys? Okay? Ito the point. Kung ato na siyang palihong driari, anak ko na siyang driari. What is the concentration of potassium? So the potassium iodide concentration is not equal to the potassium. It is not equal to the concentration of the potassium and the concentration of iodine. Okay? Because potassium iodide is the solution, and then potassium individual concentration of potassium plus concentration of iodine. So you can never equal that one unless it will never yield a number of moles 1. It will yield a number of moles 1 only in your dissociation. Now, it will not matter anymore. Okay? For example, sodium hydroxide. Ganon. And then the problem will say 0.25 molarity, 0.25 molar of sodium hydroxide. Okay? And then, if you say what is the molarity of sodium hydroxide? Of course, it is 0.25. If I will say ask also, if I will ask also, what is the concentration of sodium in that sodium hydroxide? It's also 0.25 because during dissociation in water, sodium will yield Na positive 1 plus OH negative 1. There's no number of moles here. It's still 1. Okay? What if 2, 3, 4, 5, so hindi na siya mag-equal. So, the same as the concentration of hydroxide ion in the 25 molar sodium hydroxide is also 0.25 molar. Okay? You get the point? That's why it's not the same. You get the point? Ikabungkag niya guys ba? You should be particular when the chemical compound splits after the chemical reaction. Di ba splits? Tawag ba? Splits. Splits ba guys? Or ano, detach. So, detached. So, okay. Thank you so much for watching this particular video. Okay. Why the problem is always like this most of the times? Because if you ask me the molarity, very easy to solve. Like katong sa formula ba? So kini jud ihatag pirmi sa examination ng dilution ganun, di ba? Kaya ang formula based sa molarity, ana kada siya most solute over little solution din. Say na kayo. Okay, that's why they will give this type of examples of problems in the future. Ganun. Di ba? Kaloka. Okay. Question number 3, but before that, mukhaon sa kong kabush. Bye-bye. God bless everybody. See you later for my third vlog. God bless. Mukhaon sa kong kabush mga palangga ha. Charot. Kabush. Kabush. Hoy. Kaloka.